Hey there, welcome back. In this video, I'm going to teach you a very basic overview of how a neural network works using TensorFlow. So as you can see it in your screen, there is two lists. One is features and another one is label. So I want you to find the pattern in this two list. So as you can see, when feature is 1, the label is 2. When it's 2, it's 5. When it's 3, it's 8. So what is the pattern? What is the recurring pattern in this list? Let me tell you. The feature value is multiplied by 3 and subtracted by 1. Say 3 into 1 minus 1 gives me 2. And 2 into 3 minus 1 gives me 5. 3 into 3 minus 1 gives me 8. So the pattern is 3 into features minus 1 is the value of y. So as a human being, we are able to find this pattern just looking at the data set. But what we are going to do today is we are going to use, or I would say like we are going to create a simple neural network with just one neuron, and we are going to make that neuron predict this. That's what we are going to do. So if you have clicked this video, I hope you already know a few things about neural networks, and you might have already seen something like this before. I would like to break down this diagram for you. So each and every uh, part of this is known as a layer. This is layer 1, this is layer 2, and this is layer 3. I hope you can understand what I'm trying to say. This is layer 1, and this is layer 2, and this is layer 3. And in layer 1 we have three neurons. This round circle is the neuron. In layer 1 we have three neurons, in layer 2 we have four neurons, and in layer 3 we have two neurons. Now we create these neural networks using a library called TensorFlow. First, let's start by importing the TensorFlow library, and this is how you do it. From sorry, import TensorFlow as PF and run it. Let's wait for a while. Now, I also have to import a few things to create layers and neurons. So to create layers, I need to import from TensorFlow dot keras import sequential. So using this sequential, I'm going to create this entire thing, and there is one more thing which is from TensorFlow dot keras dot layers import dense. Using this dense, I can create each and every one of this. First, I will create this, then this, then this. That's what we are going to do today. Ignore the yellow underline because it is going to work anyway. Now we have imported the things that are necessary for us, and we got the features and labels. Now let's create a model using this. I mean, to be precise, let's create a neural network. Model equal to sequential, and inside sequential I'm going to create the first layer using dense, and inside dense I'm going to specify the units, which means if I give 1, which means I'm creating just one neuron inside this. So one. So I'm just going to create one neuron, and the input shape, in our case, the input shape is one. We are going to give one input each time. As you know, when I give the input one, it is going to try to predict the label value, which is 2. That's what it is going to do. The aim of this neural network is to find the value 3 and 1, which can also be represented as weight and bias. The 1 is known as the bias and the 3 is known as the weight. This is what the neural network has to predict, because that's the pattern in the label uh, associated with the feature. So I've created a neural network with just one layer, and in that one layer there is just one neuron, which looks just something like this. That's it, nothing. That's what we have just created. This is what we have just created. Just one neuron in one layer. If you want to create two layers, you need to create another dense like this. And if you specify units equal to 4, this will create me a second layer with 4 neurons like this one. This will create something like this. This is what this will create. But for now, I'm not going to create another layer. I just want one layer and one neuron. And let's run this. What it says. Let's run this. Instead of equal to. Oh, sorry for that. I should not give that bracket, and I should close this here. Yeah, we are good to go now. Run this. Now we created the neural network. Now we are going to compile this. Model dot compile, and we need to specify two things in within this parenthesis. First thing is optimizer, and I'm going to use the SGD optimizer, which is gradient descent. To be precise, stochastic gradient descent. And I need to specify the loss. I'm going to use the mean absolute error. Let me also explain what this particular line of code is going to do. This particular line of code first predicts a random value or guesses a random value for each value in the feature, and it will compare the guessed value using the mean absolute error. If the comparison is very high, if the error is very high, it will make another guess and compare that guess with the actual value, and it will repeat that until you know until a specified epoch. We are going to create epoch right now. I will tell you how to do that as well. So I'm going to do like something like, before fitting this data to our model, we need to convert this into a numpy array. So to do that, I'm going to import numpy as, and let's use x for features. Np dot to array. No. Np dot array. I'm going to pass the features, and y is equal to np dot array. I'm going to pass in the labels. Now I'm going to run this. There is a type something. Oh, you need to run this. Let's run this as well and run this. Yeah, now we are good to go. Now I'm going to fit those data inside a model and give a epoch of equal to 200, which means the model is going to make 200 guesses and going to compare it with the actual value, and it will try to reduce the error as much as possible. That's what it is going to do. Let's run this. It's epochs, not epoch. It's epochs. Yeah, as you can see in the first epoch, from the first epoch we can see in the first epoch the error was like 22, and after each epoch the error keeps decreasing. That's what we want. And in the last it came to zero. Yeah, at the 200th epoch the error is almost zero point 0.4, which is really good. Now let's predict a value using this model dot prediction, model dot fit predict. Let's go here and do something like, as you know, for 10 we are going to get 29. What do you think we will get for 11? If it's 11, 3 into 11 is 33, and 33 minus 1 is 32. So we need to get 32. If I pass 11, I need to get 32. Let's see what this model is going to give me. Prediction. It is going to give me 31.4. As you can see, the error is 0.46202. So it has a very little error, but that is totally fine. But it is still able to predict the value. If it's 12, which is 12 into 3 gives us 36 minus 1, which is 35. Let's try 12. The model is giving us 34. It is obviously close to the actual value. So let's also check what the model has learned, like this. Model dot get weights will give me what the model has learned till now. So it had learned the weight is 2.8, which is actually 3, and it has learned that the bias is 0.18, which is actually 1. But it learned something from the data. As we have feeded the model with a very few set, like we have just feeded the model with data point of 10. We only feeded 10 points of data, and it was able to predict very closely. That's the power of neural networks compared to machine learning. So I hope you understood how a neural network basically works. It's all about the finding the patterns and how the label is related to the features, and it tries to predict the weight and the bias between them. That's what it does. And this is a very simple program that I learned recently from a book called AI and ML for Coders. It's a great book. I would recommend you to check that book out. And I hope you learned something today. Thank you.